Welcome back to Table Talks. It's Expedite again. We are still looking at the geometry, and tonight in our lesson we're going to look at something interesting, and this is called percentage yield. Percentage yield. Today we shall be discussing more about percentage yield. Now, what do we mean when we say percentage yield? When a chemical reaction is taking place, in most cases, we calculate theoretically the amount of product that we expect to come out of that reaction. But when we do practicals from experimental results, the actual values we get for the products are always less than the theoretically calculated values. Therefore, now, what causes this? The reason that leads to this, we have about 2 to 3 reasons. One of the reasons is that there is a possibility of side reactions. 2, there is a possibility of losing the products. We can lose the products. And the third reason that causes the final product to be less than what is calculated theoretically could be that some reactants do not react completely. Some reactants do not react completely. Now, when we have such a scenario where some reactants are not reacting completely, and for us in our calculation, we are trying to show, or we are assuming that the reaction went to completion. Now, when the reaction doesn't go to completion, this basically will affect the final yield. And another thing is we have reactions that are reversible. For example, if we look at the Haber process, where we have hydrogen combining with nitrogen to give us ammonia, this is the Haber process. You realize that since it is a reversible process, this nitrogen is busy being converted back to hydrogen, and the ammonia is splitting to give back these two. Now, such a reaction that has not gone up to completion, then it is very hard that we shall get the actual yield being the same as that is predicted by the calculations or by stoichiometry. Now, let's look at percentage yield and write something below it. We write and say that in practice, comma, the yield calculated theoretically is always less than what is got experimentally. Now, what causes this? Let's look at the reasons for this. We said one of the reasons is that some reactants do not react completely. Some reactants do not react completely. 2, there are some side reactions. Now, what do I mean by side reaction? That maybe, let me say, we are looking at the Haber process, where we are reacting nitrogen with hydrogen to give us the ammonia here. It is possible, if this vessel is not closed, this nitrogen can react with oxygen to give us nitrogen dioxide. Of course, when we get the nitrogen dioxide, it is not what we expected. And therefore now when we are calculating for the amount of ammonia, it will not be exact if it is true all the nitrogen had reacted with the hydrogen. So such kind of things will cause a decrease in the yield or the product. Now, we are saying that there are some side reactions. Then another thing is that reactions do not take place in the desired way. Then another reason that leads to less yield is that some products are lost. So if, like for example, we have gaseous products, what happens here, there is a possibility of the gas escaping and then we lose it. Now if we have lost part of the product, it means that the yield we are getting in the end is less than what we expected to get if all things were ideal. Now, having looked at this, how do we calculate percentage yield? Percentage yield is got from a formula. Percentage yield is got from the formula actual yield over theoretical yield multiplied by 100%. So if you don't want to say theoretical, you can say calculated yield. This will mean the same. So from this formula, we'll be in position to calculate the amount of products, the percentage yield of a given reaction. Now, we're going to look at another interesting thing under percentage yield, and here we are going to look at what we call a limiting reactant. So now the question is, what is a limiting reactant? A limiting reactant, this is a reactant that is completely consumed when a reaction is taking place. When you have 2 or 3 reactants reacting to give you products, assuming I have A and B reacting to give me the product C. If A gets used up before B, then A is a limiting reactant, and therefore it means that B is in excess. It means that B is what? Is in excess. So if we happen to calculate anything, if we happen to calculate the products formed, we are going to base on, when we are doing our stoichiometric calculations, we are going to use the limiting reactant. Now the question is, how do you determine a limiting reactant? We determine a limiting reactant by getting that reactant that has the least number of moles. So if A has less moles than B, then it means A is the limiting reactant, and when we are carrying out geometric calculations, we are going to use A. It means that we shall strictly do what? We shall strictly use A to calculate the amount of product that is produced. The reason we can't use B is that B is not reacting completely. So if we base on B, we shall have missed a point. So that is what happens under here. So let's define a limiting reactant. We say this is a reactant that is consumed completely. This is a reactant that is consumed completely during a chemical reaction. That's what we call a limiting reactant. And we say that we use, this should be a point to note, we use the concentration stroke mass of the limiting reactant, to calculate the amount of product formed. So that is what we had to say under percentage yield. We are saying that for percentage yield in the practice, the yield calculated theoretically is always less than what is got experimentally. What causes this? We are saying that the reasons why this happens is that some reactants do not react completely, and that there is a possibility whereby there are some side reactions, then the reactions do not take place in the desired way, the way we assume the reaction is taking place. At times it's not always true. Then some products are lost. For example, if we have gases being part of our products and it's not easy to contain gases, so they escape. When you're calculating how much you've yielded from the reaction, you'll get less than what is exactly was given out. Then we say that percentage yield is calculated from the formula actual yield over theoretical yield times 100. And then we looked at a limiting reactant. We say that this is a reactant that is consumed completely during a chemical reaction. Now, how do we deduce that something is a limiting reactant? A limiting reactant is that reactant that has the least concentration. That's what we use to calculate the products. So therefore, let's stop here. We shall look out for calculations in the next clip.